Hello everyone and welcome back to my channel Physics Radiate. Today we will see that how we can uh, calculate the d spacing, or we call it interplanar distance. In this case we have the perovskite XRD data, and the data were taken for the sample of the perovskite which was fabricated on the glass substrate. So this is very simple. For that we just need a little mathematical formula. For example, here we have the x-rays, which is the source in this case, and in our sample, or in our device, of the XRD device, that was copper, K alpha, and the wavelength was 1.5406, and this was in angstrom. And here we have, for example, the atoms arrangement. So this is called actually the planes, and in this case, in the Miller indices it is 100, and here it is another plane. So the distance between these two planes are called the interplanar distance, or d spacing. So the Bragg's law can be written as, and as we all know that Bragg's law is actually 2d sine of theta, that is equal to n lambda, and we can find the d, or the spacing distance, that is n lambda divided by 2 sine of theta. So here just n is the first order diffraction. Okay, this is first order diffraction, which is in this case 1. So we have n value, we have lambda values, so we just need to find out the angle, and which can be obtained from the XRD data very easily. So let me do it for you. For example, we have the XRD data. So in this case we have the theta on the x-axis, 2 theta, and this is the intensity. We just need to draw the graph, and here we will make it a little bit bold so that we can see it clearly. Now we just want to make it a little bit better, so go to the analyzer, go to the peaks and baseline, peak analyzer, and open the dialog. We just need to subtract the base, so here we have the option subtract baseline, and then click on next. Then we have the baseline mode, so it should be user defined, and then go next. So here as we can see, some of the points are upper than the peak, so we need to click on the modify, and then we can modify accordingly. So just hold it and move it down, so you can move it throughout this one. So I think this is okay. Now click done and finish it. Now go back to the book sheet. Here we have the subtracted data, so this one we need to draw it once again. So here we can see, let me do it a little bit clear, so make it a little bit bold too, and make the x-axis like this one. Okay, for example 8, and let's say 40. I'm just doing for the sake of an example, just to make it sure that you can do it for your research article or research data like this. Okay, click OK. Now we need to have the peaks value, so for each peaks we have some angle over here. This is actually, let me do it to 2 theta, and this is in degrees, as we have seen in the previous videos. and I have also the link in the description box. And this is actually the intensity of the sample peaks. So this is the intensity, and this is in atomic, sorry, in the arbitrary units. Okay, now we just need to go again to the analysis, peaks and baseline, multiple peak fits, open the dialog, and we just need to check. This is the function is Gauss function, and just double click on each peak over here like this one. Okay, okay, double click on each peaks so that we can take the angle of each peak. Okay, now just click open the fit, click on the fit until converged. Okay, and done. So it will give us another sheet of the data from where we can take the angle, go down. Okay, over here we have our data here. Just control C, copy this and put it in the Excel file. As we can see that this is the 2 theta uh, data or values, so we have to paste it over here. Once check it again. Okay, now we need actually the theta. So here we have 2 theta, so we just need to uh, actually divide this value by 2. So we just need to equal, so, and we have to divide this value. Okay, divide by 2 and just enter. Okay, and apply this for all. I think it will work like this one. Okay, let me do it. Okay, no, like this, sorry. Okay, like this. So it will divide each value by 2, as we can see from the formula that this is actually theta. So now we just need to define our formula for the D, as we can see in our formula that D is actually n lambda divided by 2 sine of theta. So here we need to define that. This is n is actually 1, and that is multiply by 1.5406. okay, this is, so here it should be like this. Okay, now divided by 2 multiply by sine of, this is just the formula we have to put for this sine. Okay, and this is in radian, it should be in radian. Okay, now we need to have this column, for example for the first one, and then we will apply, this is the theta, so we have to apply that and close. close and close it and just enter. Okay, now this is actually from the formula. It is, as we can see, n lambda divided by 2 sine of theta. So here we can apply this for all over here like this. So this is actually the interplanar distance for each value over here, for each angle for the perovskite thin film in this case. So thank you so much, and please subscribe and share, and if you have any question, let me know in the comments box. See you again.